Hi, and welcome back to the second part of Module 4, where we're going to look at what's called the rules for equivalent resistance. Now, the word equivalent basically just means total. So what we're looking at here is if you were to have a circuit. So in this case, if you have a series circuit, if you were to replace all of the resistors in that circuit with one resistor, basically you're saying that that resistor would be equal or equivalent to all the resistors that were in there. So maybe the 10 resistors are replaced by one resistor or whatever. So if you have a series circuit, it's really simple to calculate the equivalent resistance, and all you do is you add up the resistance of all of the individual resistors. So if you look at the bottom of the page, you have the equation there where resistor 1, 2, 3, etc. is, you add all those up, so the total resistance is just the sum of all the individual resistors. So that's the series rules. Now if we go to parallel rules, it's a little more complicated. So when you have a parallel circuit, if you think of the pathway of the electrons once again, the electrons have multiple pathways. So the more resistors you add, it decreases the overall resistance, okay, which means it's an inverse relationship. So you have a reciprocal mathematical situation going on. Sometimes an analogy to think through these, to understand them, to help you remember them better, is this. Think of driving down the road, and let's say it's a one-lane road, okay? One lane going each direction, so a two-lane road, but you can only drive in one lane going the direction you're going. And you have toll booths in the way. Every single toll booth, and none of this, open air tolling where you just drive through, like an actual toll booth where you got to stop and hand the person money, let's say. As you're driving through, every single toll booth is going to slow down the traffic, and the more toll booths you add along that route, the slower it's going to go. Okay, so you're going to increase the overall resistance the more resistors, i.e. toll booths, you put in the way. But in a parallel situation, now think of that one lane, and then all of a sudden you get to a tolling area and it breaks into 5 toll booths. So people will be able to pass through those toll booths more rapidly, and the more toll booths you add, the less resistance there will be at that point. So that sometimes is a good way to think about it. Now, what we're going to have to learn here before we can apply this is learn how to do some calculations. So here's the summary. And so to calculate, if it's a series situation, you just add up the individual resistors. If it's parallel, you actually have to add up the reciprocal of those resistors. So it's the sum of the reciprocals, as you can see here. But if you notice, that actually solves for the inverse of the equivalent resistance. So to find the actual equivalent resistance, you need to do the reciprocal of the reciprocals, the sum of the reciprocals, okay? So mathematically, that can be a little more challenging, but with your calculator, it's actually not too bad at all. So we're going to walk through this. So we have a 10-volt battery. It's connected in circuit to 3 resistors of 3, 4, and 5 ohms, and they're wired in parallel. So let's start by drawing. It's always a good thing to do to draw your circuit so you can picture it. So here we have resistor 1, here we have resistor 2, and here we have resistor 3. So resistor 1 is 3 ohms, resistor 2 is 4 ohms, and resistor 3 is 5 ohms. So to find the equivalent resistance, because we are in parallel, we're going to use our parallel equation. So it is 1 over the sum of the reciprocals. So 1 over 3 ohms plus 1 over 4 ohms plus 1 over 5 ohms. So I just went through the 3 individual resistors and I summed the reciprocals. Now in your calculator, get your calculator out. And if you follow along, once you get it turned on, to solve for this, all we have to do is this. We can go 1 divided by, and then open a parentheses. and then go 1 divided by 3 plus 1 divided by 4 plus 1 divided by 5. Close parentheses. So I've basically opened parentheses on the bottom and calculated it that way. And if you put it in exactly that way, you get an equivalent resistance, in this case, of 1.276. So I'm going to go 1.28 ohms. That is the equivalent resistance. And sure enough, we added resistors and our overall resistance went down, as you can tell. So we just did part B. We've done A and B. Now to do C, determine the total current within the circuit. So for this, to do part C, we're going to go back to Ohm's law. And we want to solve for I. So I is voltage divided by resistance. We're told up at the top that our voltage is a 10 volt battery. So I'm going to put 10 volt divided by our resistance of 1.28 ohms. So if we go 10 divided by 1.28, we get a current of 7.81 amps. So what's going to be important here is this. As we wire more and more things in parallel, our current goes up. Okay, the resistance goes down, which means it's easier for electrons to flow, and so you have more current. You have more electrons flowing. And eventually that can be dangerous. Just like a river, the more water you have flowing in a river, the more dangerous that river can be. So current can be very dangerous if it gets too high. And we're going to talk about why that's important in our homes in the next and last part of this lesson. So let's do one more little example. So here we have a 20 volt battery, and it's connected to a complex circuit, as we can see below. So this circuit is a combination of both parallel. So we have resistor 2 and resistor 3 are in parallel with one another. And then those two resistors are in series with resistors 1 and 4. So how would we define, or how would we find and calculate the total resistance or equivalent resistance of this circuit? So we're going to have to use both rules. So first, let's take this part and let's figure out what that is. So we know the equivalent resistance of that will be equal to 1 over 20 ohms. So right here, 1 over that plus 1 over 5 ohms, okay? So we grab our calculator, and I go 1 divided by, open parentheses, 1 divided by 20, plus 1 divided by 5. Close my parentheses, and I get 4 ohms. So while it's not necessary, one thing we could do is we could redraw the circuit, because basically what we've done now is this. Our circuit still has resistor 1 of 15 ohms. Oops, I did that a little close. So let's move that up a little bit, and now I have room to put in my little circuit. Resistor 2, we've now figured out resistor 2 and 3's together really are 4 ohms. And then we have this circuit right here, resistor 4, which is 10 ohms. So we've essentially replaced that parallel part of the circuit that had 2 resistors in it with now 1 resistor. So now, to add everything up, we have 3 resistors in series. So we can just add them up, as is the equation for that, what the equation tells us. So I can just add 15 ohms plus 4 ohms plus 10 ohms. And when we do that, we get a total of 29 ohms. So that is the equivalent resistance of the initial circuit. And then lastly, we're asked to find the total current. So we can go V is I times R, which means I is V divided by R. And we're told our voltage is 20 volts. That was given to us right here. And we know that our resistance is 29 ohms. And so 20 divided by 29 is 0.689, or I'm going to just go 0.69 amps. Okay, and that would be the current of the circuit. So when we add resistors in series, we increase the overall resistance. When we add resistors in parallel, we decrease the overall resistance. So one quick little question, we have points P and Q, and they're connected to a battery. And as we add more and more resistors in parallel to that, what would happen to the total current? Well, we learned that as we add more resistors, that's like opening more toll booths, and that will end up decreasing the total current in the circuit. So eventually, if we add so many resistors, that current gets so high that it becomes extremely dangerous. So we'll talk about how that works in our house and how our houses are wired. Are our houses wired in parallel or series, and why is that? So for now, you can start working on the next worksheet, and then once you're done with that worksheet and you check the key, then you can tune into the next lecture. It will be a little more practical application of what we learned so far. Thanks, and have a great day, everybody. Bye-bye.